So we are going to start the topic redistribution of charge. We will be starting this topic with an example. Let us have the system of two containers where these two containers are connected with each other by a connecting pipe. If these two containers are carrying liquid up to different levels, we know the liquid will flow from higher level to lower level, and this flow will continue until the level of liquid in both these vessels become equal. Now, even when this flow stops, we can clearly judge that the container which has greater base area will contain greater amount of liquid as compared to another container. This is because this container B, has greater capacity than container A. So container B will be carrying greater volume of liquid. This example can be used to explain the concept of distribution of charges also. Now let us suppose we have two spheres, one of radius r1, another of radius r2. Let charge given to sphere 1 is q1 and charge given to second sphere is q2. Now due to these charges, they will develop some potential. So potential attained by first sphere, let it be v1, and attained by second sphere, let it be v2. Now when we connect these two spheres with each other by some connecting wire, the flow of charge will start. We know charge will flow if there is some difference in potential. So this difference in potential between V1 and V2 will make the charge to flow from one sphere to another sphere. Now let us suppose these two conductors have different capacities C1 and C2, and they are already carrying charges Q1 and Q2 respectively. Now the charge distributes in these two conductors in the ratio of their capacities. Which one will carry greater amount of charge will depend upon their capacities. Higher the capacity, higher charge it will be storing. So we can easily relate this example, this scenario with the example we have done earlier, that the container containing larger amount of liquid is because it has greater capacity. Similarly, we can say the conductor having greater capacity will attain greater amount of charge. Now charge redistributes till the potential of these two spheres become equal. Thus, let us suppose Q1 dash is the final charge attained by first sphere and Q2 dash is the final charge attained by second sphere. Therefore, we can say Q dash, new charge attained by any of this sphere, is proportional to capacity of that sphere. So we can easily write Q1 dash is proportional to C1 and Q2 dash is proportional to its capacity C2. So from here we can write Q1 dash over Q2 dash is equal to C1 by C2. So the charge attained by any sphere will be proportional to capacity of that sphere. Now we know that capacity of a sphere depends upon radius of that sphere. We have done in the previous topic. because we know capacity of a conductor, if it is a sphere, was equal to 4 pi epsilon naught r, where r was radius of that sphere. So we can say C1 will be proportional to R1 and C2 will be proportional to R2. So simply we can write C1 by C2 is equal to R1 by R2. So we can also use this relation to write Q1 dash by Q2 dash is equal to C1 by C2 is equal to R1 by R2. So this is the relation between charges attained by spheres when they are connected with each other, their capacity and their radius. This relation we have to keep in our mind. Next we will be doing the topic that is common potential. Now before starting that topic, we know when we are connecting these two spheres with each other, the flow of charge continues between them until they attain a common potential. When the potential of two spheres becomes equal, the flow stops. So we will write common potential. Flow of charge stops when two conductors attains same potential. That same potential is called common potential. Called common potential. So now we will be driving the expression for this common potential. How you can calculate this common potential and what is the value and how common potential. So we are starting with common potential. Now here we will be taking example where we have two spheres carrying charges Q1 and Q2. Radius of two are R1 and R2 and having capacity C1 and C2. So clearly, according to conservation of charge, when these two spheres are joined by a conducting wire, the total charge will remain conserved. Let the new charge on sphere 1 is Q1 dash and new charge on sphere 2 is Q2 dash. Let these be to the two new charges. Now we know by the relation Q1 charge on first sphere is equal to V1 C1. Similarly, Q2 is equal to V2 into C2. So when we join these two, the total charge will be equals to Q1 plus Q2, and this total charge will be equals to C1 V1 plus C2 V2. So from here we can say that total charge is equal to C1 plus C2 into a common potential V. Because when we join these two conductors, they will attain a common potential. That is, V1 will become equals to V2 and that is equal to V, a common potential. They will attain a common potential when these two spheres are joined with each other. So from here we can simply find the value of this common potential. So from this relation we can calculate the common potential is equal to Q1 plus Q2 over C1 plus C2. So this is a very important expression for common potential and this will be used in numericals further.